A matrix is a way to represent a table of values, and this is done in what's called a rectangular format or a rectangular array of numbers. One possible application for matrices that will be seen in other videos is matrices are there to represent a series of simultaneous equations. Let's have a look at some of the terminology used to identify various parts of a matrix. Each horizontal line is called a row. We can see here it's pointing at the first row of 3, 5 and -1. So this matrix has two rows. A column refers to a series of values in a vertical line. So in this case we can see that we've got the first column is 3 and 0, and then the second column is 5, 2, and the third column is -1, 4. The number of rows and columns give the dimensions of a matrix. So this matrix is called a 2 by 3 matrix as it has 2 rows and 3 columns. Let's have a look at some other examples of matrices and what their dimensions may be. Before we have a look at the dimensions, note that for each of these 4 matrices, each matrix is identified by a capital letter. Here we can see matrix C has got 2 rows indicated by the red ticks, and we've also got 3 columns indicated by the blue ticks. So that's a 2 by 3 matrix. Matrix D also has 2 rows indicated by the green ticks, and we can use asterisks to indicate the columns. So that's also a 2 by 3 matrix. Matrix M has got 2 rows indicated by the red ticks, and the asterisks show that there are 2 columns. So that's a 2 by 2 matrix. And matrix P has 1 row indicated by the blue tick, and we've got crosses to show the 4 columns. So that's a 1 by 4 matrix. Each individual entry in a matrix has its own position. So we can see here the entry in red, A11, represents the entry in the first row and first column. The entry in green, A23, represents the entry in the second row and the third column. We show these positions using subscript notation, with the row number first and the column number second. Some matrices are defined by their dimensions. So any matrix with only 1 row is called a row matrix. It has dimensions 1 by n, where n is any positive integer and it represents the number of columns. A column matrix is any matrix with only 1 column. It has dimensions m by 1, where m is any positive integer and represents the number of rows. We also have square matrices, and in each case the number of rows equals the number of columns. We can see here 3 different types of square matrices. We've got a 1 by 1, a 2 by 2, and a 3 by 3. So any square matrix has the dimensions n by n, again where n is any positive integer. The main diagonal of a square matrix is shown in this diagram, and it consists of the entries in the positions in the first row and first column, the second row and second column, etc., all the way down to the nth row and nth column depending on the size of the matrix. A zero matrix is one where every entry in the matrix is 0. So regardless of the size of the matrix, if every single entry is a 0, that is a 0 matrix. 2 matrices are said to be equivalent if they have the same dimensions and they have matching entries in every position.